This diagram from Hardware Universe depicts a chassis with one storage controller module. Become familiar with the I/O port icons and colors, which are used in most storage controller and cabling diagrams. Making the conceptual leap from diagrams to physical cabling can be difficult. You start by learning how to cable a single-node cluster to one shelf stack. A single-node cluster is the smallest NetApp ONTAP cluster possible. Learning how to cable a single node prepares you to cable larger clusters. The scenario uses one fast storage controller with two onboard SAS ports and quad-port SAS host bus adapters, or HBAs, in expansion slots 3 and 4. The storage controller attaches to one shelf stack, which is composed of 3 NetApp DS2246 drive shelves. The first step of the port selection algorithm is to write down all the unused A ports on the storage controller. You can write them on whatever you have at hand, or you can fill out the cabling worksheet in the shelf cabling documentation. The matrix that is shown here is only a subsection of the entire worksheet. Next, write down all the unused C ports. This system does not have an onboard C port, so you record only the C ports on the PCIe cards in slots 3 and 4. The next step is to identify all unused B ports and write them on a line below the A and C ports. In the worksheet, you use the top half of the boxes in the second row to record the port numbers. Next, record all the unused D ports. Again, because this storage controller does not have an onboard D port, record only ports 3D and 4D. The next step of the port selection algorithm is to eliminate single points of failure, or SPOFs. If you pair ports 0A and 0B, you create 2 SPOFs. The first SPOF is that the ports share an ASIC. The second is that the ports are on the same circuit card, in this case, the system board. If you shift the first entry in the row of B and D ports to the end of the row, and then shift all ports to the left by one column, the result is 5 sets of port pairs without any SPOFs. On the worksheet matrix, record the shift by writing the new port numbers in the bottom half of the boxes in the second row. Using the first pair of ports from the port selection algorithm, use the 0A port to create the primary path to the first shelf in the shelf stack. The secondary path from the last shelf in the stack goes to port 3B. Note, the SAS port PCIe cards in slots 3 and 4 are represented vertically only for illustration purposes. In most storage systems, expansion adapters are installed in horizontally.